This is a video on evaluating functions. So we have a few different scenarios that we're going to run into. Here we have functions in equation form. We have functions in table form. And we have functions in graph form. So let's start at the top. If we are told that t of x equals 9x minus 24, and we're asked to find t parentheses 8, or t of 8. What that means is that the x value of my function needs to be 8. So I'm going to rewrite my function. But instead of x, I'm going to put an 8 in. Okay. Now, granted, this function in and of itself is not that complicated. We could have multiple x's. There could be some fractions, some exponents, whatever the case may be. Here, it's 9x minus 24, and instead of x, we put an 8. Order of operations tells me to multiply first to get 72 minus 24, and we get 48, and that is the answer for t of 8. So the output for an input of 8 in function t is 48. All right, we could do something similar for w. I could do w of, let's also do 8. And again, looking at my function, this x is going to become 8. So I'm going to take 1/4 parentheses times 8 plus 7. Multiply. 1/4 of 8 plus 7 is 9. So the answer on that one would be 9. So that's one aspect, and that would be when you are given an x value. But what if you're given the value of the function? In other words, the output. So what if I told you that w of x is equal to negative 11? And I want to know what x value would result in an output of negative 11. So opposite of what we did here, where we took x, or 8, and replaced it with x, we want to know what x is. So we have this value is negative 11. So I'm going to rewrite my equation as negative 11 equals 1/4 x plus 7. Now this assumes that you've done extensive work on solving equations. So if you don't understand the next few steps, you probably want to look at that. Here the 7's cancel. We get negative 18 equals 1/4 times x. To cancel the 1/4, we would multiply by 4. And we get negative 72 equals x. That is the x value. That gives us w of x equals negative 11. So if I were to give you w of negative 72, like we had done over here, the result is negative 11. So in one side here, these values, you are plugging in an x value. In this type of problem, you're plugging in this whole side, this whole part of the function. These problems, you're going to be given this similar information. So I'm just going to slide this a little bit this way. Well, I'm going to try. And I'm going to slide this graph down a little bit so that I have room for both. All right, so this chart or table, okay, one thing I could ask for is, what is a parentheses 4? So this represents the input, which is the m. I go down to 4. What is the value of that function at 4? The answer is 17. Now it might be a little bit different than that. I might ask you, let's find A of 5.5. Notice that you don't find that here, okay? And it might even say to estimate. So we know that it's halfway here. So the best that we can do is use these two values and find something right in the middle of them. 18.35 would be right in the middle. Okay, and instead of equals, I might just cover myself by saying approximately 18.35. I can also work the other way around. I want to know what happens or estimate what value of m gives us a of m equal to 15. Oh, here's 15. Perfect. I would say 3. M equals 3. Now, similarly, what if I said A of m equals 10? Now, clearly, we don't have a lot of information here. We certainly don't have 10 here. It appears that the function is constantly increasing, right? 4, 9, 15, 17, 18, 1, 18, 6. So it does look like it's constantly going up. We don't know that for sure because we don't know what's happening in between. So my best guess, though, is something really close to 2, right? 2 is 9.3. So I'm going to say m is approximately 2.1, 2.2. And as long as it's ballpark where it needs to be, I'm going to be okay with that kind of estimate. And we might need to estimate on these too. Okay, I think the graphs are the most interesting because you have all kinds of information. You can infer. If you know something about lines, in this case, you can actually use your knowledge about linear equations to actually find out more information. Let me line this up so that the points are on the grid. All right, let's look at finding, this is A of m again. I probably should have mixed it up. Let's go with A of 5. Again, this is my input, so I'm going to use that information. I'm going to go to that value on the horizontal axis. So 5 is here. Once I get to 5, I go up until I see what the value of my graph is, and the answer is the y value for that x value. All right, so if I did A of 4.5, again, we're going to estimate. It's good to use the estimate symbol. 1, 2, 3, 4. 4.5 is here. Go straight up. And we're looking at this number here, which looks like to be about 3,500. Now, if I wanted to change that, if I said, okay, tell me the m value for the following situation. When is, or what months is there a balance of $4,000? So to me, what I like doing there is I like to draw a horizontal line. Now I have the capability of moving that, but you would want to draw it right at 4,000, and you can kind of see that at $4,000, our graph has 3 instances of that occurring. We have it here. That is an x value of 0. We have it here, just a little above 1, and we have it here, just a little above 4. So I know it's 0. I know it's about 1 point. Let me just double check that again, just a ballpark. Probably 1.3 or 1.4 would be an estimate that I'd be okay with. Again, approximately. The m value for this point is about the same, 4.4-ish. Okay, and when we're looking at graphs like that, estimates are sometimes more than adequate. And that's how you evaluate functions.